we'll see how to find out the equation of tangent line of a curve where two surfaces intersect. Okay. So let me write down the question here. Find the parametric equation of the tangent line to the curve of intersection of the ellipsoid. So we have two surfaces. The ellipsoid is given by x square plus what? 1 second. 2y square plus 2g square equal to 20, and the paraboloid whose equation is given by x square plus y square plus g equals to 4 at the point 0 comma 1 comma 3. Can you see the question, Mayan?
Yeah.
Okay. So can you read it, please?
It says find the parametric equation of the tangent line to the curve of
Intersection.
intersection of ellipsoid x squared plus 2y squared plus 2z squared equals 20, and the paraboloid x squared plus y squared plus z equals 4 at the point 0, 1, 3.
Yes. So we have two surfaces. That two surfaces intersect along a curve. We will calculate the tangent line of that curve at the point 0, 1 comma 3. So before doing so before writing down the step, so let me draw a picture for your understanding. So first, see, ellipsoid, if you draw, it will be here like this. So let me take here x-axis, I mean g-axis, x-axis, y-axis, g-axis. So this is x. Although it is difficult to draw the graph, for the surfaces always, but it is easy to calculate. If you know the method how to do, you can easily calculate the tangent line at least. So here you have the origin. So now, you know, the ellipsoid is just the three-dimension version of the ellipse, right? So you have like that. This is the ellipsoid. So you can think your ellipsoid is this. So this way. Mine. Okay.
Yeah.
So this is the ellipsoid. So this equation is given by, I'm trying to draw it, but I'm not sure that I can draw the exact graph, but just I'm drawing for your visualization. So now let me draw the paraboloid. The paraboloid will have the vertex at the point, the 0 comma 0 comma 4, maybe this place. So this is 0 comma 0 comma 4, and it will go down. It is opened this way. So this way. Okay, Mayan?
Yeah.
Right. So look at this. The intersection is this, right? This is the intersecting part. So they will intersect. So I think okay. All right. So the intersecting part will be a circle, right? I'm just drawing this side, the front side of the circle. This is the intersecting circle. Mayan, okay?
Yeah.
This is the, yeah, x square plus y square plus g equals to 4. Yeah. So they intersect, through a circle. That is the green circle I have drawn here. So I mean, basically, I put the green color along the intersecting line. It is a circle. Now we have a point on it. Where it is? The point is 0, comma 1, comma 3. So x is 0, y is 1. So y is 1, x 0, y 1, and g3. So here, this place. So let me use this black color. So here, this is the point, right? So this point I called the P point. Mine. Okay.
Yeah.
Right. Now we calculate the equation of tangent line. So basically a line. So let me that touches the circle, this green circle. So basically it will have the form something like that. So we calculate the equation of this yellow line. So see, to write down the equation of a straight line, we need a point and we need a vector parallel to the straight line. Right, Mayan? Mayan, okay?
Okay.
Very good. Now look at this. At the point P, if you consider the tangent line, tangent plane of this, the paraboloid, then the yellow line lies on the tangent plane, right? Got it, Mayan? If you take,
Yeah.
yes, tangent plane of the paraboloid at the point P, then the yellow line lies on the tangent plane. Similarly, if you consider the tangent plane of the, you know, the ellipsoid at the point P, then also the yellow line lies on that tangent plane. Mine, it is clear.
Right.
Okay. Now see, we can immediately calculate the normal vector of both tangent plane, right? Right, man. Okay.
Yeah.
All right. You can say in a different way that if you consider the tangent plane at the point P for both surface, then you know that two tangent plane will intersect along that yellow straight line. Got it, man?
Yeah.
Okay. It's a little bit, difficult to draw the picture, but I think you getting my point, right? Are you getting my point? What I'm saying?
Yeah.
Okay. So we have now the situation. We have two plane. This is for the ellipsoid, and then we have here the red color. So let me write here. So here the red color we have like that, right? This way we have the tangent plane for the, you know for our paraboloid. So the intersecting line we have here, right? This situation we have the intersecting line, right? So maybe let me, I don't know, maybe here this place I'm drawing for convenience. Okay. Now we have here the point P. Now we have the normal vector here for this tangent plane here. This, so this is nothing but the gradient of. So this is, the gradient of, if you say the ellipsoid F. So F at the point P, and also we have the normal vector for. So here we have normal vector this way, right? This is the gradient of G at the point P. If you call G of the paraboloid. Mine, okay?
Yeah.
So now if you take the cross product of these two vector, then you get a vector parallel to the yellow line. Got it? This is gradient of f at p cross gradient of g at p. So this is a vector parallel to the tangent line. Mine, clear?
Yeah, clear.
Okay. So to write down the equation of tangent line, we have to calculate gradient of both surface, and then we have to take the cross product of that two gradients, and we get the vector which is parallel to the tangent line. So first let me write down the function f of x, y, g, that is nothing but the first function ellipsoid x square plus 2y square plus 2g square minus 20, and let me take g x y g for the paraboloid x square plus y square plus g minus 4. This mine. Okay.
Yeah.
Okay. Now calculate gradient of f at x, y, g. Can you tell me the gradient of this function? It will have component del f del x. We take the partial derivative of f with respect to y and g. Now tell me what are the component? Please first. Can you tell me first? This is f function. Can you tell me del f del x? Mine.
Del f del x is x squared. No, sorry, 2x plus 0 plus 0.
Okay. So
Okay, so
2x.
just 2x.
What is del f del y?
Del f del y is 4y.
Very good. Del f del
And
z?
then del f del z is 4z.
Very good. This is gradient of f function. What is gradient of g function? Similarly do it. You have the formula for g. Tell me what is
Yeah.
del g del x?
2x, then 2y, then 1.
Very good. 2x, 2y, then 1. Now calculate at the point. The given point is 0, 1, 3. So now if you calculate this gradient at the point 0, 1, 3, this means you are putting x equal to 0, y equal to 1, and g equals to 3. Right, Mayan? So
Yeah.
if you put in this formula, so what should we get? We get 0, we get 4, and we get 12. All right. So gradient of g, then at 0, 1, 3. I just putting x equal to 0, y equal to 1, and g equal to 3 in the formula. Okay, Mayan?
Okay.
So then here we get 0, this. Now I putting in this formula. 0, then 2, and 1. So these are two gradient vectors of the function f and g at the point 0, 1, 3. Okay,
Okay.
right. So now we calculate the cross product of these two. Then we get a vector. That vector will parallel to the tangent line. So now if we calculate gradient of f at 0, 1, 3 cross gradient of g at 0, 1, 3, what should we, you know how to find out the cross product? If you have two vector, first you have to write I cap, then you have to write j cap, then you have to write k cap, then the component of the first vector. What is the component of the first vector? It is, you have written basically, so let me write down here. So it is 0, 4, 12, right? Mine 0, 4, 12. And what is the next? The next is 0, 2, 1, right? So this, mine, is it okay? See,
Yeah.
because our gradient of f at this was what? 0, 4, 12, and gradient of g, yes, at 0, 1, 3 is what? 0, 2, 1. So this, so therefore, the cross product, when we calculate, we have to write determinant of I, j, k. Then the component of the first vector, it is exactly 0, 4, 12. and second vector 0 to 1. Now you expand this determinant with respect to the first row. So then what should we get? Block the first row, first column, then you get the coefficient of I. So this is 4, 12, 2, 1. Here I cap. Then minus sign, block the first row and second column, then you get 0, 0, 12, 1 of j cap. And plus they block the first row, third column, so 0, 4, 2, sorry, 0, 2, then k cap. So what should we get? We get 4 minus 24 of I cap minus 0 minus 0 of j cap plus 0 minus 0 of k cap. So we get here minus 20 of I cap minus 0 of j cap minus 0 of k cap. Right, mine? Is it clear?
Yeah.
Okay, very good. Now we have the point. So we are ready to write down the equation of tangent line. Point is given by 0, 1, 3. And the vector, the parallel vector, you can say the parallel vector. Parallel vector are given by negative 20, 0, comma 0. Right? Point is this, parallel vector is this. So equation of tangent line. So we are going to write down the equation of tangent line. So basically we are writing the equation of line. So when you are writing the equation of line, we need a point. Exactly it is 0, 1, 3 here. And we need a vector parallel to the line. So that we are getting from here that, negative 20, comma 0, comma 0. So equation of tangent line you can write now. Line is given by parametric equation will be what? X equal to x naught. X naught means 0 plus t into the first component of parallel vector. Y equal to 1 plus t into the second component. G equal to 3 plus t into the last component. So what should we get? We get here basically x equal to minus 20t, y equals to 1 and g equals to 3. Mine, is it okay? Mine, clear?
Yeah, it's fine.
So this is the parametric equation of the tangent line at a point of that intersecting curve. So this is very important question. They can ask you from here. They will give you two surface and then they will ask you find the equation of intersecting, the, tangent line to the intersecting curve at that given point. So they will ask you this kind of question. Mine, are you sure you can do this kind of question?
Yeah, this is fine.
Okay,
This is no problem.
all right. So how you do this? You will calculate gradient of both function. Then you take the cross product. Of course, you calculate gradient of the given point. Exactly, we did it here. This you have to first to do. Then you have to take the cross product and you get the vector that will be the parallel vector to the tangent line. So you have a point and you get a parallel vector to the line. So you immediately write down the equation of tangent line. Because if you have a line and if you know a point x naught, y naught, g naught, and if you know a vector parallel to that, say a, b, c, then you can immediately write down the vector equation, parametric equation, symmetric equation. Right, Mayan?
All right.
Okay. So that we have used here basically. Yeah. Now here one more concept they can ask you the angle of inclination of a plane. So let's say you have, I don't know, they will ask this type of question. Maybe let me solve one question with you. So here, a question. So let me, before go to the question, let me tell you little bit concept, what we are going to do now. So the angle of inclination of a plane. Mine actually in the first day test, uh, do they cover all the topics or I mean up to 13 point, let me say the 13.7 like that? How much they will cover in the day one, man?
Um, I think all from 13.6 to 13.10.
They will cover all.
I think so, but I should ask him tomorrow and
Okay.
make sure. I'll let you know tomorrow for sure.
Okay. We will
Um,
get one more class, right, man?
I'll wait. I'll take a screenshot and I'll show you what it says.
Screenshot of what? This.
Here I'll post it in the WhatsApp.
Okay. All right. All right. Okay. You'll send me the screenshot
Okay,
of
there.
no. Okay. 1 second.
I'm pretty sure it's all of it.
Okay. Let me take the Monday problem session, Thursday, Wednesday review. Friday chapter 3.6 to 3.10. We are at 3.7, right? Where we are now? 13.7. We have more three. I think we get one more classes, right? Your
Yeah.
Your Friday mean my Saturday? I don't know.
Uh, Wait, say that again?
What is the day your today?
Today for me is Monday.
Monday. All right. So your Friday mean my Saturday. Okay, I think we get two more
Yeah,
classes.
your Saturday.
Yeah, yeah. We get
Two
two more.
more? Okay,
Yeah, two more class. But it's okay. I have to
sure.
review also with you. You question.
Yeah.
All right. Okay. So let me tell you the next idea, the angle of inclination of the plane. I'll tell you little bit, the overview what we have done. So the formulas and the concept. I'll tell you for 5 minutes. I will give you overview today. Okay. So here,
Sure.
okay. So let's say you have a surface. So of course the level surface we consider here. So you have a level surface here. So let's say you consider the x-axis, y-axis, and z-axis. So this is x, this is y, this is z. Mine actually see, when you did the two-dimensional calculus, I mean the function, if you have y equal to fx function, if you have, then what should we did? Basically, if we consider a point P, then we are interested about the tangent line, right? How much angle it make with the positive x-axis, right? That we call the inclination of the, the tangent line, right? Right, man?
Yeah.
Okay. Now, since we are working with the, the surface, so this is the 3D version of the curve surface is, and so the 3D version of the line is the plane, right? So this is the tangent plane. So let's say we have a surface here. I don't know, maybe this way we have a surface. So this is the surface. Let's say something like that. Okay. So you have a surface. Now we have a point on it. Let's say P point, and let's say we considering the tangent plane at this point. So you have the tangent plane here. Okay, man.
Okay.
Right. So now this is your tangent plane of the surface at the point P. Let's say this is your P point. This is P point. Okay, this is tangent plane. This is surface. This is tangent plane at a point P. So in two dimension we have a curve and we have a tangent line at point P. Now see, at the point P, we are considering the tangent plane, right? Now we naturally we can claim that how much angle it make with the xy plane. I mean, yes, the xy plane. So it will intersect here, right? The xy plane at through this line. So let me put it here. So intersect through this line, right? Mine, is it okay?
Yeah.
Okay. Now we are interested to find out the angle between xy plane and the tangent line, right? Fine. Okay, man. So this means,
Yeah, I'm just thinking. Okay.
okay, say, let me tell you again. We have a surface in xy, in the space. We consider a point P on the surface. Then we consider the tangent plane of the surface at that point. Then that tangent plane will make some angle with xy plane. This is the xy plane, right, man?
Correct.
Okay. Now we are interesting to find out the angle between tangent plane and xy plane. That we called the angle of inclination of that plane. Got it? Mine.
Yeah.
Okay. So how we do that? So basically, if you have two plane and if you want to calculate the angle between two plane, then it is enough to find out the angle between the normal vectors of two planes. Right, Mayan?
Right.
Okay. Now what is the normal vector of the tangent plane? We know that it is the gradient, right? Mayan? Gradient of
Mm-hmm.
f, yeah, at the point P. So this is the normal vector. So this is normal to the tangent plane, right?
Yeah.
And what is the normal vector of the xy plane? It is k cap, right? Because k cap is the, this is the k cap. Got it, Mayan?
Yeah.
Okay. Now to find out the angle between, so just we calculate the angle between these two, right? So this angle we calculate. Fine.
Fine.
Okay. So let we have a level surface. We have a surface. Let's say, let me write it in the form f of x, y, g equals to 0 and a point, and P is a point, A, B, C is a point on it, on surface. So the angle of inclination of surface, this term they will use, the angle of inclination of the surface at the point P equals to angle between, angle between the gradient vector of f at the point A, B, C and the k cap. Mayan, okay? So basically the,
Okay.
okay. So how we get this? So that is given by, cosine inverse of, if you have two vector A and B, then, and the angle, let's say angle between them is, let's say theta, then what should we know? We know cosine theta equal to what? A dot B divided by the magnitude of A, magnitude of B, right, Mayan?
Yeah.
So then theta, yes. How you get theta? That you is nothing but cosine inverse A dot B divided by magnitude of A and magnitude of B. Okay, man, clear?
Yeah.
Okay. So how we calculate that then? So basically the angle of the between these two vector will be, so just if you know, because first you have to calculate gradient. If you know the idea, you can calculate it. So second, so it will be basically, so this, so it will be basically gradient of f abc dot k cap divided by magnitude of the A, B, C and K. I'm just writing, not necessary to write this because you can calculate. If you know this, that we have to calculate angle between gradient and K, then you just put in the formula cosine inverse A dot B divided by magnitude of A into magnitude of B, like that. Okay, Mayan, clear?
Okay.
So every place we are, we are, we are checking the, we're looking at the application of the gradient vector, right? Just we are every time we are calculating gradient of a function in this chapter, right, Mayan?
Yeah.
Okay, let me tell you one example. Here, example. Find the angle of inclination. Find the angle of. So this, the angle of inclination has importance. When you will do the multivariable integration or the vector integration, we'll talk about the projection. But since your course is not containing those, so we're not able to see the application of this concept, angle of inclination. Okay, man. But
Okay.
yeah, angle of inclination has many applications, especially when you are doing vector integration. Actually, I taught this your elder sister, this multivariable course when I took. She she did basically, yeah, vector integration. So that, you know, yeah. Okay, no problem. So the find the angle of inclination of the tangent plane to the ellipsoid. To the ellipsoid, so it is given by x squared divided by 12, y squared divided by 12, g squared divided by 3 equals to 1. At the point 1 comma, sorry, 2 comma 2 comma 1. Okay, mine clear?
Yeah.
So the solution, yes, we do this. So first we write down the function. So your function f x y is what? This is basically x square by 12. Yes. Are you saying something? Are you
Wait,
asking?
what?
Are you asking something, man?
Am I? No, I'm not.
Okay. So let's calculate the gradient. So the gradient of this function at f x y g equal to, tell me, del f del x will be what? And del f del y. What is this? Del f del x? It will be 2x by
Del
12. So x by 6.
del of the x will be 2x over 12. Del of the y will be
Mm-hmm.
over 12, and then del of del z would be 2z over 3.
Yes. So at the point 2 comma 1 comma 1, so you have to put 2. So 2 over 6, 2 over 6, 2 over 3. So we are getting 1 over 3 comma 1 over 3 over 2 over 3. So angle of inclination equals to cosine inverse of, we know we have to take dot product of this with k cap, right?
Yeah.
So so k cap divided by magnitude of 2 comma 2 1 and magnitude of k cap. So what should we get? We get cosine inverse of, this is basically 1 over 3 1 over 3 2 over 3, this dot 0 0 1, right? And then magnitude of this 1 over 3 1 over 3 2 over 3, that magnitude, and k cap magnitude is 1, right? Is it okay?
Yeah.
Right. So what should we get if you simplify? So then you get cosine inverse of the top, you get here basically 2 over 3, because 0 into 1, 1 over 3 into 0, 1 over 3 into 0 plus 2 over 3 into 1. So 2 over 3 divided by square root of this. If you simplify, then you get here. So after simplification, so this will be basically square root of 2 over 3. Okay, mine.
Yeah.
So what should we get? Yeah, I'm writing here. So we get cosine inverse of square root of 2 over 3. So this is nothing but approximately 35 degree, 35.3 degree. Mine. Okay.
Yeah.
So that's the idea. Yeah. So this chapter we finished basically. Now the next chapter is extremum of a function of two variable. Next two chapter. Okay.
Yeah.
So let me send you the image basically. Is all this. Yeah. Did you understand, man?
Yeah.
Lots of things we have done here basically, but all easy. You have to little bit review, right? Everything.
Yeah.
Okay, I'm recording the video. You can see after class also and sending the image also.
Sure, sure, sure.
Yeah, that will help you because we have less time. But yeah, you can do great. So one exam we did wrong. I mean, the very badly we did, right?
Yeah.
That's why the grade is less. Otherwise, it's okay. All right. So should I stop here or I send you the new link for the next? I think we did lots of things, right,
Um,
today?
yeah, we can stop if you want.
Okay. So basically, see, man, let me tell you little bit overview what we have done today class.
Sure, sure.
So yeah, I mean, in this chapter, this is 13.7, right, man? What we are doing? We are doing now, yeah, 13.7. So we basically, in the 13.6, what we have defined? In the 13.6, we defined basically the gradient, right?
Yeah.
Yeah. So this is the gradient. We did it in 13.6. And 13.7, what we are doing? We are in we are actually looking at the application of the gradient, right?
Yeah.
Application, yeah, of gradient. So basically where tangent plane, right?
Yeah.
Yes, normal line, tangent tangent line of intersection of two surfaces, right?
Yeah.
And inclination angle. These four fundamental concepts we have done by using gradient, right? Because gradient is basically, if you look at gradient is, normal to the tangent plane, right?
Yeah.
So this is the point A, B, C. Yeah, so we write down the equation of tangent line, we write down the equation of the normal line, all the things. And the if you have two surface intersect through a curve, so at some given point on that curve, we can write down the equation of the tangent line. And angle of inclination. So this is called inclination angle or angle of inclination. That's all. Okay, man. And what we do in the next, that also the application of gradient 8.9, 13.8 we see. So extrema of two variable. Okay,
Yeah.
extrema of two variables. Yeah. And in the next chapter, we'll see the Lagrange multiplier method. Okay, man. I mean, that will
Sure.
be, yeah. I mean, then in 13.9, we see application of this application maximum minimum of two variable. We see the application, and then 13.10, we see the Lagrange multiplier method. Okay.